All right, so what we are going to do today is we're going to learn other fancy stuff you can do. But I will start with saying that you have to be conscious of when to apply them. And so please try to pay attention. And my course notes are a little behind, but I want to finish them up by the end of today. Please pay attention to when you actually need to use something. So the nice thing about SQL is that you don't write an algorithm, right? You write a logical statement of what the answer should be, right? So your SQL is kind of a description of what it is, and that's a feature. It is not an algorithm. In fact, the idea is that when you write SQL, it can be translated to many different algorithms. Consider each algorithm as basically a combination of relational algebra operators. But you can write many different ways the same exact SQL expression using relational algebra. And what will happen is that when you execute SQL in any database system, your SQL will first be translated to relational algebra. But then the database system will actually look at different ways of writing the same query using different relational algebra. And it's going to have different methods that you can use. So you can write it as Q1, Q2, Q3, many different ways that you can execute the same query. And then it is going to look at how you actually store your data. And is it distributed? Does it have this index or that index? And then choose the lowest cost method. And this whole method, this thing is called query optimization. And one of the main reasons that you buy databases is that you buy a sophisticated query optimization engine. This is, decades of programming, time that has gone into refining this. It has lots of sophisticated technology behind. We will talk a little bit about this, but it's impossible to talk about all the details in this class. But the point is that your job is not to really write an algorithm in SQL. For the most part, you want to write a query for which it is easy to find different ways to execute the same query. And you will sometimes say, well, I'm smarter than the database, so I know that if I wrote it like this, it will be easier to execute. Sometimes you may be right, bless you, but very often you will be wrong. In fact, we will see you can give hints to the optimizer, say, why don't you do that? And 99% of the time, the optimizer will reject your because the optimizer is using a multi-criteria optimization that's hard for you to process. But we will see that there are sometimes reasons to do certain things. So this is why I have been kind of hammering you with, you have to write simple logic. The simple logic meaning that select from a whole bunch of relations and where is all the join conditions, because that's really, the databases are optimized to do that, right? So they are optimized for, in fact, figuring out how to execute joins efficiently. And whereas if you write your query in a different way, the database may not be able to see that there is an optimization, but now it's not possible for the database engine to see that it's equivalent to what you wrote. So, but that doesn't mean that you should write crazy joins everywhere. But it is important to understand that simple expressions are simpler to optimize. And in the more sophisticated new databases, sometimes there is no difference. If you go and get a job and you have an older legacy database, that may be a big deal. So it is important that you be flexible, you understand the differences, and that you can write something simply, and then you can choose to go to a more complicated statement because there's a reason to do so. So we will see different ways to do the same thing, but it is important to understand that the more complex does not always mean more efficient. So, keeping that in mind, let's try to solve the one that we just had. I understand was very difficult, which I kind of knew when I was writing it. And let's see. And my answer looks like something like this. Well, let's see if that's really correct or not. All right, so so let's just start slowly. And in fact, probably it's easier to just use an editor for this. Okay. Remember that I basically always start from the from statement. And then I'm going to add complexity as is needed, right? So, for example, it asked for students S and transcript T, such that the student is taking a class in, what was it, fall 2015? And that the student has not finished the class, so T dot grade is null, or T dot grade is equals incomplete. And then the course for this class is offered for the major of the student. Okay, so now I need to find the major for this class, so that is in courses. So I'm going to say T dot course ID is equal to C dot ID, and that T dot major is equal to S dot major. I'm sorry, C dot major. Okay, so far so good. No big objections. And that the student has taken this course at least a second time before, meaning like one more time before. I understand. I just wrote second just to confuse you to see which one you're going to count and which one you will not count. It was kind of just trying to be mean. So basically, I want to see that the student has taken the same course before, right? So for that, which relation do I go to? Transcript again, right? So I need to go back to transcript, T2, to find that T2 is again by the student, and that T2 is for the same course. And that the student has completed this class. T2.grade is not null. And T2.grade is not equal to I. And that T2 was a semester before T, right? So either that T2 year was before T year, right? So if it was offered before, it was in a previous year, or that the years were the same, but T2 semester was spring. How do you like that so far? Okay. So that should take care of 1, 2, and 4, but it doesn't take care of that the class meets in 2 different days, right? So now I need to go back to meeting times. And I'm going to call that MT. Okay, so I have meeting times for this specific course. So mt.course ID is equal to t.course ID, and mt.semester is equal to t.semester, and mt.year is equal to t.year, and mt.section is equal to t.section. And beware that you can obviously also write fall here, that the result should be the same. But if you have the same constant 2 times, you can make an error. So it's kind of easier to do it like this. Okay. So far, this is the part that is tricky now. Now I have this huge tuple where I have student matched with a course that they took in fall. That's matched with some other course. So if there are many other courses, you may have multiple tuples. And then that's matched with the meeting times. So basically you have combination of, for a given student and course, meeting times and the previous times they've taken it. So you may have many tuples, right? So if I were to count the number of tuples, that doesn't tell me how many meeting times that course has, because you are multiplying that by as many as there are T2 tuples that match. Okay? So this is the part where that becomes tricky. So that's why I wrote this first to say, find the number of tuples in meeting times that match. But that doesn't work because this T2 will basically have a multiplication effect. So that count may not be correct. This is the kind of stuff you have to be aware of in the next homework. So because of that, I can group by T, but then I cannot count the number of tuples, but I can count distinct values. So for example, I can write something like group by s.id, s.name. You don't need to do name, but you know, if you get an older database, this will not work. See that you can have c.id and c. course name. And I want to return those having count distinct t dot and t dot days equals to 2. So this is what I want to return. Okay? So this is what that kind of is. So this is the most the trickiest part of this query is to understand that if you did count star, this would not work. Because suppose the course is offered for 2 days, but you had taken the same course before 2 times, right? So instead of those 2 days, you actually will have 4 tuples, right? Because you have it for every combination. There is no join between MT and T2. Okay? So this is an example of a query where you can ask, why did I have to couple T2 and MT? Maybe I should have done a little differently for this, right? Or that if you wanted to return both the number of times you've taken it and the number of meeting times, this will not work because you cannot do this, okay? So because of this, now we can have more fancy ways of doing the same thing, but it's important to kind of have a mental vision of what is the limit of what you can do with a single select from when. So that brings us to what I want to talk about today. Do you have questions on this? Simple? Okay. All right. So what I want to talk about today is basically different ways to do fancier things, but to understand when they are necessary. So one of the first things we are going to look at is inner join, inner SQL, and outer join. Okay. Now, if you have been playing with the university data, I have actually added some new tuples because I wanted to illustrate some new things for you. So if you go to the database, you should have new tuples in there. So what I added was that you can have students who may or may not take classes in transcript. Okay? So, but I did not do it for this. All right, of course. Of course, that was not this. I think I did. Why? I thought I saved it, but I didn't. All right, let's try this then. So I'm going to add some tuples that do not have anything matching in the other relation, just so that I can illustrate this to you. Which I thought that I put online. Oh, yes, I put it online on the course website, but I didn't put it online on Dropbox here. All right, so sadly, it is not here. So, so basically, we can download this new script here. This is the problem with working with multiple computers. Um, All right, so now we have 6 students, but only 5 of them are taking courses, right? So which student is not taking any course? 431, right? So the point is that whenever you do a join, there is a basically understanding that you are only returning things that have matches between the two, right? So whenever you are doing, let's say, R join S, you are basically returning, and some condition, you are returning tuples from R and S that match the C condition, right? So for example, if I had student and transcript on, let's say, the ID is equal to student ID, I'm only returning you students who have taken a class, right? So as a result, 431 will never be returned. So, so this will return you only students who have taken a class. The other way is by far, of course, it's always going to be true, right? Because all transcript tuples should have a student, so you're never going to have a student that doesn't match. Unless you had some other reason that you excluded some students, each transcript tuple should match the student. But if you actually had a subset of students, that could also be true. So implicitly, student and transcript, the join will eliminate tuples in student or transcript that don't satisfy the join condition. So if I were to write, students S and transcript T, where S.id is T.student ID, and then I return you distinct S.id, this will obviously return you 5 students, because 431 has no classes. Okay? So what if I wanted to actually retain the tuple from student that did not match? That is where we are going to talk about outer join. To be able to do outer join, we are going to learn a slightly different syntax for the join that we have this. So this is the basic join syntax that we have been using. But those of you who have done SQL probably have seen that you can also write the same thing as that join in the from statement. So you can actually take a whole join and push it to the from statement. There is absolutely no difference between writing a where statement or a join statement here. In fact, what will happen is that this join statement will be really expanded to the where statement like we had. So they are, for intensive purposes, they are the same thing. But this is basically a different syntax for the same thing, and this should return the same exact result as the previous one. But now with this syntax, I can describe the type of join that it is. So the join that we generally do is either called a join or an inner join. So the idea is that there is no difference between a join and an inner join. So think of this as follows. So suppose you have tuples in R and tuples in S, okay? And you are doing R join S. And let's say that you are joining on attribute B, okay? So you have A1, B1, A2, B2, and you have B1, C1, and B3, and C3. Okay. So when you do an inner join, the only things that you will get is the tuples that join from both of them. So basically, since you're doing a join on B1, on B, the same B value is going to be inner join. Okay. And now we are going to basically assign sides to these relations. So R and S, which one is left, which one is right? R is left? Right, not by what I'm studying, but R is left and S is right? So the things in the left relation, this is the one thing that's hardest for me. So this is your left relation, and this is your right relation, right? So the tuples in the left relation that are going to be eliminated because of the join are the A2, B2, right? So this is basically the tuples that are being eliminated from left, and these are the tuples being eliminated from right. So if I were to do a left join, I'm going to get whatever is in the inner join as well as whatever would be eliminated by the left. If I'm going to do a right join, I'm going to get whatever would be eliminated from the right plus the inner join. And the full join is going to be both. So if you want to see this in action, we can actually do this. So let's create table R with as so I will add A1, B1, and A2, B2. And I'm going to do the same with S. And I'm going to have B and C this time. And then I will insert into S values B1, C1, and B3, C3. Or you can do the same thing by saying select from R join S on this. Now, if I want to retain the tuple that is eliminated, now I need to do left join. So instead of saying R join S or R inner join S, I'm going to say left join. So when I do a left join, what you will end up with is the inner join plus this tuple that would have been eliminated, but given there is no matching tuple in S, you're going to get null values, right? So if you did the same thing with a right join, you would now do the reverse, right? You will then get this tuple that would have been eliminated, but null values here. If you want to keep both of them, then you are going to do what we call a full join, which will have both of them. Okay. Now, left join, it kind of, you say, what is the point, right? But once you master it, it will actually do lots of interesting things. So let's do a very simple query. let's find for each student in the database number of classes they attempted. We can later change this in a different way. Number of classes they attempted. We can also think about number of credits they attempted or they passed, right? So we can write this in various different ways. So if I write this in the usual way, I guess I'm going to take this here. I am going to join students with transcript. I am going to group by student ID so that I am going to return for each student total number of tuples. Okay. And you can return the ID, you can return the name, and you can return as num attempted. You can return some t.credits. No, we don't have credits. We'll do that later. Okay. So what is wrong with this query? What is wrong with this query? So it does return for each student total number of courses. Yes.
And this is the one student who takes 0 courses?
Right. So do I want to return the student who has 0 courses? That's a valid answer, right? That student took 0 courses. So, but there is no way I can ever return that with an inner join. So what I need to do is instead, I will do instead of this left join. When I do left join now, I will have students who have, taken or not taken, and I will be able to return this. So let's do this. Is this correct now? So now I do return 431, right? But I still am saying that it attempted 1 course. Why?
Because even though the transcript that was a null, it still processes 1 nil.
Because when you do count star, even though it's a null, it counts as a tuple, right? So you want to actually count the values. Instead of counting star, I need to count, for example, some attribute from T. Because I know for a student who have no courses, the T values are all going to be null. So you can do any one. So I think I'm going to do this one, which is the easiest one. Right? If you wrote this query without left join, you still can, but it would be extremely complex, right? So you have to write the first query, and then you have to write a second query for people with no courses, and then return the constant 0. Whereas the single join will make your life so much easier. In fact, what if I want to find faculty who teaches no courses, right? Previously we learned that you can do that by doing a set subtraction, right? You do find all the people who have classes, subtract all the faculties, from that subtract the courses that the faculty who teaches courses, right? But I can do the same thing, but in a slightly different way. Find faculty who teach no courses. So I'm going to do faculty F and course classes, okay? And then left join classes C on f.id is c.instructor.id, okay? So now I'm joining the faculty with classes, and on the faculty ID is equal to an instructor ID. So if the faculty told a class, there's going to be a matching tuple. If the faculty never told a class, then what will it be? Yes?
What the class that ID equal, just one exists, so it'll be null.
It will be null. Anything that's from the classes relation will be null. So in that case, I can write something like where C dot instructor ID. I generally like to use an attribute that I know for a fact that is going to be null, right? Because there will be nothing that is null. And now I can return f dot ID and f dot name. Do I need to write distinct? Can I return two tuples for the same faculty? No, because since no tuple from class is joined, this will never actually have multiple tuples for a faculty for this specific query. Okay. So this would have been the same, but I would have to write the same query something like this. Select f.id, f.name from faculty F, except, now I have to write the same thing, except class is C, where f.id is c.instructor ID. Right? So these are all the faculty, and these are all the faculty who have taught a class. So this should return the same result. Now, which one is easier to write? Which one is more efficient? Okay. So do you think the top one is more efficient than the bottom one? It will depend on how efficient the left outer join or left join implementation is. But you can see that that join already is here, right? It's just I'm telling it not to get rid of the values that don't join. So once you get used to this, you can do lots of set subtraction by the simple logic, right? That the outer join will give you so much. And you can actually do these kinds of things just to show you. So you can actually nest them. So for example, we said that left join on transcript T on s.id is equal to t.student ID. Okay, so let's return s.id and t.course ID, t.semester, t.here, t.section. I have been putting these queries online on Piazza if you want to ever get them. So now this is a join, but for each student I match the classes that they took, plus this, doesn't have this one. What if I wanted to find also, this is only for classes that actually have a student in them. What if I also wanted to add the courses to this? So I can basically say, okay, I want to add the courses that have been offered. So I want to, let's see, where was the courses? The classes that have been offered. So these are all the classes that are offered. So I want to now add that one. So I want to take this. And here you can put a join, like classes C, and then put the condition here that t.semester equals c.semester and t.here equals c.here and t.course ID is equal to c.course ID and t.section is equal to c.section. So now what happens here to classes that are that have no students in them? Okay. So I had 16 rows here, but now I have 15 rows because what did I do? I had this tuple that was null, right? Then I added a join condition here, which eliminated that null value. So I no longer have this information anymore. So now, since I had this next join, if I wanted to keep the student still, I need to take this whole thing to another left join. So in fact, I need to do left join on this. Okay. So whenever you have multiple left joins, you have to continue following that if I have this relation and I want to add another one with a join, I still now need to take, student left join with transcript and decide whether this tuple to keep or not, whether it joins with the next relation, right? So you have to continue typing whatever the left or the right is. So this is author join. There will be some author join definitely in the next homework, but this is not all. But wait, there's more. Any questions on the left join? Okay, so this is where it becomes very important to be aware of what you're doing with null values. Okay, so the next thing we are going to learn is basically, so left join is kind of a very useful thing. It's not necessarily an advanced feature that gets you in trouble. But now we are going to see advanced features that get you in trouble. So let's look at queries specific way. So we are going to look at two types of queries. So you will have general queries and scalar queries. So general queries is basically any query you can treat as a general set of tuples, right? So I know nothing about them. That is basically any query I can treat as a general query. Since a general query returns you a bag of tuples, right? So generally returns bag of tuples. I can treat this as if this was a table that was stored. I'm going to treat it as a virtual table. Even though it is not stored, I can treat it as if it was stored as a separate table and then do something with it. So going back to this query, or let's see. So for example, I had this query for each student return the number of courses that they have taken. And what if I want to take this and then do a join with something else? So let's see what I can join this with. Maybe this is too complex to start with. Let's try a simple one. So let's say from students S, where major is PHYS, let's start with a simple query. So okay, so these are all the students in this major. So now you can say, okay, given that I have all these students in this major, I want to find which classes that they have taken. So what you can do technically, not that you should do, now treat this whole query as if it was a relation. So I can say, okay, take this query and put it in the from statement. So I'm going to treat this whole thing as a relation, as if it was a table, and I'm going to give it a name. Let's say PHYS students. Okay. And now I can write additional queries, for example, where I can say GPA is greater than 4.0 and select s.name. Okay? So this is the kind of thing that we are trying to get you to be aware of, with relational algebra. What will happen with this one? So, and let's call this PS and PS.GPA. See? Because now the s.name is gone, right? So basically what did you do is you actually took the relation and you constructed, well, let's do a different thing, okay? So, so you no longer have S, you only have PS. All right, it may be that it requires an S, right? Basically, I constructed a totally new relation called PIHS students that have only two attributes, ID and name, right? And beyond that query, the s.id is gone. So you no longer have S, you just have PHYS because you have actually renamed it. So let's do this as P students. And P students, that's easier.
So then we need to create that having the interselect statement that as P students?
I think that works too. Let's see if it's as. So generally as is for the thing, but let's see. Yeah, that works too. So, so what would happen if I asked for example, where students dot GPA is greater than 4.0? What happens? The P students is no longer has GPA because I actually in the inner query extracted everything other than ID and name, right? So it's like you project it out. So once you're outside of that query, you cannot really use GPA because GPA does not exist. I just defined a totally new virtual table that only has ID and name. And you cannot also do s.gpa because s does not exist either. I've constructed a totally new relation. And it says I cannot find a table named s because s is gone. Okay? So, so basically you have taken a query and you treated it as a black box, but this black box P student has only two attributes, ID and name. But you do know that whatever is in P student is only people in this specific major. So, so this is kind of the idea that you can take a query and plug it into from statement and then use that as if it was a relation. So you can in fact, for example, take this and join it with transcript. For example, you can say t.studentID is equal to s.id, p_students.id, and then you can return p_students as well as t star. Okay. So you can take the p students and join it with something else. It's just that it's a new relation that has two columns. Now, do you get anything from doing this? Can you write this query without this inner statement? Can you write this query using a simple join? Come on, wake up. I know you have an exam after this, but still you have to be semi-awake for me. I know I'm sure that I made you too tired, but please follow on. So I can write the same thing with using a simple join, right? There's no reason that I need to do it like this. So I can say students S, right? and S dot major is equal to DHYS, right? And this query is identical to the other one. Yeah, thank you. So that's the distinction. There is, okay, so there is no performance gain by doing your inner query versus this. There's absolutely no gain. In fact, there could be a penalty. Because what will happen is that you put that query there, and depending on how sophisticated your database engine is, it may not see an optimization for doing the join, right? So one of the things is that you're telling it, you better first select on major, then do the join, but maybe there is actually an index that allows you to do join faster, right? So in fact, doing it like this will be a penalty in some cases, and there's absolutely no gain. But when you first learn SQL, you write it like this because it's easy to think in small terms, right? First I create this relation, then I create that relation, and I join that. So conceptually that's easier, but it is not in any way better. But there are cases where you have to do it like this, and that's the case where you have, an inner query where you compute some number, and then you basically, want to use that number later. Like for example, you want to find, let's say, find all students who are taking a class with 2 meeting times or something like this, right? So now you can have an inner query that computes number of meeting times, then join with that. So that's okay. So you can do that. So you can say something like from meeting times. All right, this probably will be too long to write right now, but I will write it in a second. Okay, so you can have a inner query with courses with 2 meeting times, and then in your from statement you join that with, let's say, students S, where other conditions. Okay. Because if you were to, let's say, take the meeting times and join it with something else, you're going to multiply the tuples, like we were just doing with the quiz question. So that's kind of the reason why you would do it. Otherwise, I recommend that you don't do it. Okay? All right, so that was easy. How about scalar queries? So these are queries that you know for sure return a single value. How can you know that the query will return a single value? What kind of queries return a single value? Aggregators, right? So if you have an aggregation, it will return a single value. Sometimes if you select on primary key, that will also return a single value, but I'm not sure if that's always caught by the database engines. If that is the case, then you can use your query and plug it in any place that requires a value, right? So plug in query to treat it as if it's a constant. Well, that's kind of interesting. So let's say, for example, let's say I have transcript T, where T.student ID is equal to 5, and this returns the count star, or some, no, counts. I know for a fact that this returns a number and a single number. Oh, come on. Oh, because we don't have 1, 1, we have 231. Right? I'm I'm going to pick a smaller one, let's say 215. So these are the number of courses that the student name 215 is taking. What if I want to find all the students who are taking as many courses as student 215? Okay, so I want to find courses, find students who are taking at least as many courses as student with ID 215. Okay. So, well, I can take my query. So I have student S, transcript T, and I'm going to even do a left join just to be fancy. Transcript T on s.id is equal to t.studentid. Okay. Now this is going to tell me how many courses the student S is taking. To find the number of courses for student S, I need to do a group by. So I can say group by s.id, s.name. Now I'm going to look at how many courses the student is taking, including 0, right? So the count can actually be 0 because it's a left join. Now I want to return the student if the count here is as many as the courses that are being taken by student 215, right? So which was what? 3. Okay, so this is what I want. So I want to return then s.id and s.name. Which I can never learn to write, students. Okay, so there are in fact 3 students who are taking, including the 215 herself. Okay, but now instead of 3, I'm going to plug in the query that returns the 3, right? So basically all I need to do is, I need to say, here, put this query that actually returns 3, which I know. So this is what I keep talking about nested queries. And it's going to get a little bit worse in a second. All right, so this is a query that I know returns 3. So I am going to do the same. This works because the count greater than 3 can be substituted by a query that returns 3, right? And this is kind of a nice simple query because this query here, this thing, is in no way related to the outer query, right? This is just a standalone query that returns a number that you can check if it is greater than or not. In fact, you could also take this count query and you can plug it in the select statement, right? If you wanted to, you could also say, for example, in addition to this SID and SName, I can put a query here that returns a number. Okay, as num classes. Okay, so I can in fact plug that right here, and basically for every tuple I return, it's going to have exactly the value 3, right? If you wanted to return things like, for example, how many tuples in fact there are, you could actually t.studentid as num classes taken and num classes by 215. Okay. So you can take a query, as long as it returns a single number, you can plug into the select or the where or the group by, any place where you have an expression that returns a value. Okay? Be very, very aware that this does not always make sense. because this is actually a lot of work. So you don't want to do this unless it is explicitly needed. So, any questions so far? Yes.
So, if, for example, there where you're generating the story twice in the same or I guess, what happens if someone wanted to change the value? Like, is that time?
It depends on how you locked your database. Okay? So, technically, it can change while you're executing it, so that it may get different results, but often that you lock it enough that that will never happen. But what what was I going to say? But what will most likely happen is that the database system will recognize it's the same query, right? Depending on how you wrote it, and it will actually execute it only once, right? But ultimately, you really should not write that query, right? Remember, with great power comes great responsibility. There is no reason to write it like this. So it is important that you realize what you can write without resorting to scalar queries like this. What's important, you see that you sometimes need it, then that is the right time to do it. Now, this query is kind of simple because it doesn't actually refer, it's kind of a standalone query. So this is called an uncorrelated query. Okay? And we can do uncorrelated queries and use their result in different ways too. So you can also do the following. You can take a query and you can treat it as a bag of values. And generally, you want to have a query that returns a single thing, but that's not very important. And you can check if a value is in that set. So you can take a value and check if that value is in the set of values or not in the set of values, or the value is greater than or equal to all values, or greater than any value, or not equal to any value, or not equal to all values. Okay? So basically, you're doing kind of a simple set operation of taking a value, comparing it with others. So just to show you how that would work, let's write a simpler one. So, okay. So I have, for example, grades for people. I can actually say something like where the grade is in a set of values. So for example, I want to only find the grades that are B or B minus, and maybe A minus. Okay. So you're saying that for each tuple, check if the grade is one of these three values. Instead of doing it like this, I can write a query that returns the grades that satisfy the same thing. So instead of writing it like this, I can write where grade is in, select grade from transcript, where grade like a%, or let's say any B, and or grade is equal to a something. Okay. So you can actually try and see what happens with this first query. Okay. Because I did not actually select for like. Okay. Or you can say, okay, grade is equal to A minus. Okay. Now you can write the same query, but instead of checking that the grade is in that set you explicitly wrote, I am going to set if the grade is in the set of values returned by this one. Okay? So it kind of gives you the same result. But again, conceptually sounds like it's easier to write, but it's actually less efficient. In the same way that when you write it like this, you may lose an optimization that you would not if you wrote a join. Can I write the same thing using a join? I don't even need a join, right? I have to just write the grade condition in there. So the most important thing that I would like to say is that anytime you have a positive statement like in, it does not give you any expressive power. You can write a query that you write with in without using in, right? So nothing new is gained by this one. It sounds kind of conceptually easier, but no new expressive power. Now, it is true that there are some really edge cases where you may get something that you cannot write otherwise using in, but very often you can do it using a join. Not in is not the same, because this is a negation. So I can use not in to do some better things, like, for example, I can find faculty who are not teaching a class. So I need to return everything from faculty, where f.id is not in the set of faculty who are teaching a class. So select instructor ID from classes. So this is the same query that we wrote using except, the same exact query that we wrote using left join. It gives you the same result. Which one is more efficient? It's very debatable. Okay? It is possible that this is not so bad because you only have to run the inner query once and then check against it instead of multiplying with a join. It really does depend. How about the others? For example, so not in is like except, which is new. How about is not equal to any? What is that logically the same as? Let's see. Equal to any is logically the same as? Is in. Not equal to all is the same as? Not equal to any is the same as not in, right? No, I think it's this one. And there is one final one that I'm going to write here. Exists or not exists. This is the one that everybody has difficulty with. Okay? When you have exists or not exists, then you basically have to check if the set is empty or not. So exists A is true if there is a tuple in A, and not exists A is true if there is no tuple in A. Case in question, I can write the same exact query that I was writing like this. But slightly differently. So I'm going to write the same exact query. Find all faculty who are not teaching a class. So I want to return a faculty F if for that faculty F, there does not exist a class such that return the faculty if that faculty is not teaching a class. So return the faculty if for that faculty F, the tuple F, there does not exist a class that has the same ID as the faculty. Say it again.
So the inner select is like
All right, so now this is when things get interesting. This is a correlated subquery, right? So you actually have two queries, but there is a correlation. So this is where you have to be a little careful. So you have an outer query and an inner query, right? Because you had select from where, and you have, some condition like not exists, and then you have select from where. So the inner query can see whatever the outer query can see. So basically the idea is that we said, okay, from faculty F, now think of this like a algorithm. So for each faculty tuple F, go and execute the whole inner subquery. For each tuple F, you have values, right? So the faculty is fixed, the ID, and so on. For each faculty F, execute this whole subquery. And for that faculty, find if c.instructor ID is true. So write this query and execute it where c.instructor ID is equal to 1 or equal to 2. For each different faculty, you are going to re-execute this inner subquery. And then check if it returns any tuples at all. And if so, then this will fail. Otherwise, it will not. And in fact, it's even more tricky than that, right? Because of the way you execute SQL, you can only see things that is in the from. You cannot see things in select because select comes after, right? Select is the last thing you execute. So from the relations, from the Cartesian product of tuples, look at the values for those tuples and construct this inner subquery. And then check if that inner subquery returns any tuples at all. So correlated subqueries are much more inefficient. And in this case, they are logically the same, but sometimes they are necessary. Okay? Because I'm actually creating a query for every single value. So remember that the scope goes as from faculty F into the inner query. What if I define inside another faculty F? Right? So the scope is that the nearest one to me overwrites the further one. So if I have a faculty F in inner query or anything defined as F, I will always see the closest to me. But if I don't see it, then I will see things that are outside of them. And then you can have many levels of nesting, and you always look from the lowest point higher up to find the variable that is defined. Global variables are good now, right? So you can find, as long as you can match the variable that you're looking for, you take that value. So we're going to do more examples on Monday, okay? And then kind of see equivalences. But I want to give you some time to relax and get ready for your exam.